On to linear versus nonlinear equations. So here we're focusing on first order equations. So linear versus nonlinear, looking specifically at first order. So first up, we're going to talk about just the differences in the types of solutions. So for linear first order equations, so y prime plus p of xy equals g of x, right? For linear first order equations, all solutions will take the general form. Or fit the general format. So what I mean by that is you can find some C so the general form matches the solution. For nonlinear first order, this is not the case. So for nonlinear first order, so we just have y prime is equal to some function f of x comma y. There are solutions that do not fit the general format. So there may be solutions that do not fit the general format. And in this case, what we're talking about, for example, are the constant solutions. So next up, we're going to talk about intervals of validity. So for linear functions, so for linear first order, if we have, again, y prime plus p of x times y is equal to g of x. And then let's say that we have initial condition, y of x naught is equal to y naught. What we have is that if p of x and g of x are both continuous, on the open interval AB containing x naught, then the solution y the solution y to the IVP, initial value problem, is a solution on the entire interval AB. This is not true for nonlinear. So for linear, all that we really cared about was where P and G are continuous around X naught, right? For nonlinear, it turns out that the initial condition for Y also matters. So for nonlinear, first order. So again, y prime equaling f of xy with initial condition y of x naught is equal to y naught. The interval of validity for the solution to the IVP will depend on both x naught and y naught. So this piece here is our new part that's key. That interval of validity will not just be based off of the initial condition for x, but also on the initial condition for y.